Hi there everyone. So for today you're going to learn about kinetic and potential energy. Alright, so for potential energy, the definition is it is a stored energy that depends upon the relative position of various parts of the system. Examples, okay, shown on the picture. Okay, the first one here on the left, okay, you have the boy aiming to shoot, and here you have the girl who's going to start the slide. Okay. We have here another example. It is the boy just sitting on the ground. Okay, we have a parked car and a ball. It's not moving. So we have to know the opposite of the potential energy, which is the kinetic energy. So when we say kinetic energy, is the energy that it possesses due to its motion, or it is defined as the work needed to accelerate a body of a given mass from rest to its stated velocity. Examples here, you have on the left, okay, the car moving, and the second here, you have the girl swinging. So we have other kinds of pictures here for the kinetic energy. At the top, okay, the roller coaster in motion. So below that, okay, you have an example for the bowling and hitting the bowling pins. And the third, okay, on the right side, you have the basketball wherein the ball is going to shoot on the ring. So in learning potential and kinetic energy, we have to consider the following factors that affects them. And so for the potential energy, we have the mass, height, and gravity. So let me explain why mass is a factor that can affect the potential energy, because the higher the mass, of course, it has higher potential energy. How about for the weight, for the height? Okay, so for the height, we have the higher the position of the object as it falls, so it means that it has higher potential energy. And for the gravity, this is constant. Like on Earth, we have 9.8 meter per second squared, and this is constant. So gravity, it depends on the uh, part of the universe, or maybe with regards to the difference in the planets, right? So next we have here the kinetic energy, and in terms of the mass, so how does mass affect the uh, kinetic energy? So it means that if the mass is higher, the kinetic energy is of course higher. And for the velocity, this means that it is actually referring to the changes, okay, of the motion or the direction. It can be accelerating or decelerating. And the force, so of course if the force is greater, the kinetic energy is higher or greater. So one of the ways to prove in science is to have an equation about the potential and kinetic energy. So for potential energy formula, we have to use PE, which means that it is the potential energy is equal to mgh, wherein m stands for the mass, the unit is kilogram, the g stands for the gravity, with constant on Earth, it is 9.8 Newton or meter per second squared, or Newton per kilogram. While for the height, okay, that's of course the unit is meters. So therefore, it is PE, potential energy, is equals to mass multiplied by standard gravity multiplied by height. Example problem solving for potential energy. So we have to use the formula. Potential energy is equals to mass multiplied by gravity multiplied by height. Okay, for the given here, you have 4 kilogram as the mass. The distance is, or the height is 10 meters, okay, above. And we have 4 kilogram rock on a 10-meter cliff. Okay, so for the solution, potential energy is equal to 4 times 9.8, the standard gravity, multiplied by 10, and you have 392 joules. All right, for the kinetic energy solving problem, example, what is the kinetic energy of a 45 kilogram object moving at 13 meter per second? So first, you have to identify the information given in the problem. Mass is equal to 45 kilogram, velocity is equal to 13 meter per second. Next, we place this information or the data into the kinetic energy formula. Kinetic energy is equal to 1/2 mv squared. So this one should be the square, since it's squared, the 2 is above the v. Okay, so we have kinetic energy is 1/2 multiplied by 45 kilogram. Okay, that represents the mass, and the velocity, which is the v. Okay, so 13 meter per second, and then squared. So 45 kilogram, multiply that by 169 meter per second squared. So you get 7,605. So the kinetic energy value computed is 3,802.5 joules. You need to divide this by 2, okay? Because as stated on the kinetic energy 1/2. So please don't forget this. Okay. So to divide the 7,605 divided by 2 to get the computed kinetic energy value, which is 3,802.5 joules. So note that the kinetic or the unit of energy is the same as for work, the joule or J.